Hello everyone. In this video, we are going to discuss about two laws of chemical combinations. One is law of multiple proportions. Another one is Gay-Lussac's law of gaseous volumes. See, we have already discussed about the other two laws, law of conservation of mass and law of definite proportion in our previous video, which will be available in the playlist. So let us see what is this law of multiple proportions state. See, law of multiple proportions, this law was actually proposed by Dalton. According to this law, if two elements can combine to form more than one compound, the different masses of one element that combine with a fixed mass of the other element are in the ratio of small whole numbers. What does it actually mean? Let us consider the two elements hydrogen and oxygen. You see, by combining hydrogen and oxygen, we get more than one compounds. That is, by combining hydrogen and oxygen, we will get water. Actually, its correct formula is what? 2H2 plus O2. It gives 2H2O. Then only 4 hydrogen atoms, 2 oxygen atoms. So anyway, here we are taking, when we consider water, it has 2 hydrogen atoms and 1 oxygen atom. Okay, by combining the same hydrogen and oxygen, we will get another compound which is hydrogen peroxide, H2O2. So you see, by combining the same hydrogen and oxygen, we get more than one compounds. Okay, so here you see, by combining 2 atoms of hydrogen with 1 atom of oxygen, we will get 1 molecule of water, H2O. So here 2 grams, 2 atoms of hydrogen, no? So 2 grams of hydrogen combines with 16 grams of oxygen, okay, which gives 18 grams of water. And here you see H2 plus O2 gives H2O2. So 2 grams of hydrogen combines with 2 oxygen atoms, no? So 16 into 2, 32. So 2 oxygen atoms, that is 32 grams, which gives 34 grams of hydrogen peroxide. Okay, see, in the two reactions, mass of the element hydrogen is fixed 2 gram, 2 gram, but mass of oxygen, that is different. That is, different masses of one element, that is oxygen, combines with a fixed mass of other element, that is hydrogen. Now, the ratio of masses of different mass element, that is oxygen, is 16:32. That will be equal to 1 into 16, 16, 2 into 16, 32. So 1:2. See, what do you mean by all numbers? 0, 1, 2, 3, 4, 5, etc. No? 0, 1, 2, 3, they are all numbers. So you see, the ratio is the ratio of small all numbers. Okay, that is what this law states. Now, let us see what is this Gay-Lussac's law of gaseous volumes. You see, this law was actually given by Gay-Lussac in 1808. And according to this law, when gases combined or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at same temperature and pressure. You see, this law is actually applicable for the reaction of gases, that is for reactants as well as products, but they should be gases. Now let us see what does this law actually means by using some examples. For example, suppose hydrogen gas combines with oxygen gas and gives water vapor, that is in gaseous form. Okay, so 2H2 combines with oxygen gives 2H2O, and you see this is in the gaseous form. Okay, so you see, when gases combined or produced in a chemical reaction, they do so in a simple ratio by volume. That means 2 volumes of hydrogen 2H2, no? So 2 volumes of hydrogen reacts with 1 volume O2, no? So 1 volume of oxygen to give 2 volume of water. Okay, so 2 volumes of hydrogen gas combines with 1 volume of oxygen gas to give 2 volumes of water vapor. Okay, that is if we have 100 milliliter of hydrogen gas, that is 2 volumes is equal to 100 milliliter. Then what about 1 volume? That will be 50 milliliter. So we have 15 milliliter, oxygen gas. They combine together and gives 100 milliliter. 2 volumes, no? So 100 milliliter water vapor. Okay, so here gases, oxygen and hydrogen, they are combining. Okay, so their ratio, the gases which are combining here are oxygen and hydrogen. So their ratio, that is hydrogen and oxygen, their ratio will be what? 100 is to 50. Okay, that is the ratio of their volume. 100 is to 50, that will be equal to 2 is to 1. Okay, so you see the ratio is actually a simple ratio. That is what this actually means. Now, let us consider another example. Here, hydrogen gas combines with chlorine gas and gives HCl gas. So, you see, one volume of, that is when gases, as per the law, when gases combine or produced in a chemical reaction, they do so in a simple ratio by volume. That means, here 1 volume of hydrogen reacts with 1 volume of chlorine to give 2 volumes of HCl. That is, if we have 100 milliliter of hydrogen, then 1 volume reacts with 1 volume. So 100 milliliter reacts with 100 milliliter. Okay, so 100 milliliter of hydrogen reacts with 100 milliliter of chlorine. Then we get 2 volumes of HCl gas. That is, we get 200 milliliters of HCl gas. Okay, now, so here the ratio of gases combined together will be what? 100 milliliter is to 100 milliliter. That is, this will be 1 is to 1. 1 into 100, 100, 1 into 100, 100. Okay, simple ratio. Now let us consider another example. Here methane gas combines with oxygen gas to give carbon dioxide gas and water which is in liquid form. So if we have 100 milliliter of methane, then how much oxygen is required here and how much carbon dioxide is formed? How can we calculate this? See, we cannot talk about the water here because it is not in gaseous form, gaseous state. So why? Why? Because this law is actually valid for gases only. So here you see we have 1 molecule of methane and 2 oxygen. So we can consider 1 volume of methane combines with 2 volumes of oxygen gas to give 1 volume of carbon dioxide gas. We cannot talk about this water because it is in liquid form. So if we consider, if we have 100 milliliter of methane gas, then that is 1 volume reacts with 2 volumes. So 100 milliliter will react with 200 milliliter of oxygen gas to give 1 volume, that is 100 milliliter of carbon dioxide gas. That is, this is actually the volume. Okay, so according to this, how much oxygen is required? 200 milliliter. How much carbon dioxide is formed? 100 milliliter. See, Gay-Lussac's discovery of integer ratio. So here you see the gases combining are methane and oxygen. So their ratio of volume 100 is to 200, that is 1 is to 2, a simple ratio. So you see, Gay-Lussac's discovery of integer ratio in volume relationship is actually the law of definite proportions by volume. Law of definite proportions by volume. Alright. So in this video, we have discussed about the two laws, law of multiple proportions and Gay-Lussac's law of gaseous volumes. I hope it is clear to you. We will be discussing about the Avogadro's law in the next video and Dalton's atomic theory, atomic mass, molecular mass, etc. in the coming videos, which will be available in the playlist. Thank you.